Here is an example regarding scalar product between two vectors a and b, where a is 2i plus j minus 2k, b is I plus j. Part 1. Find the scalar product of a and b. Recall that if you have a vector involving I, j, k, that means a is a1i plus a2j plus a3k, b is b1i plus b2j plus b3k, then the scalar product of a and b is equal to a1 times b1 plus a2 times b2 plus a3 times b3. Here, a is 2i plus j minus 2k. b is 1i plus 1j and 0k. So, you multiply component-wise. 2 times 1, you get 2. 1 times 1, you get 1. Minus 2 times 0, you get 0. Add together, you get 3. So, in conclusion, the scalar product between a and b is equal to 3. Next, we are going to find the angle between a and b. How do I find the angle between a and b? I have this vector a and a vector b, and the angle between them I want to find. We have to link it to the geometry. Remember that in the earlier definition of scalar product, a dot b, or the scalar product between a and b, is equal to magnitude of a times the magnitude of b cosine theta. And on the earlier part, we found that the scalar product between a and b is equal to 3. And then you're going to find the magnitude of a, which is magnitude of 2i plus j, which is 1j minus 2k. And the magnitude of b, which is 1i plus 1j and 0k. And cosine or angle theta. So in order to find out what is theta, you need to find the magnitude of 2i plus j minus 2k and I plus j plus 0k. Let's find out what are these values. Recall that the magnitude of a1i plus a2j plus a3k is equal to square root of a1 square plus a2 square plus a3 square. So the magnitude of a, which is equal to the magnitude of 2i plus j minus 2k. 2i plus j minus 2k is equal to square root of 2 square plus 1 square, as this is 1j, plus minus 2 square. And this will give me 4 plus 1 plus 4 is 9. Square root of 9 is 3. Then you have to find out the length of b. b is equal to I plus j, which is 1i plus 1j and 0k. And this is equal to, the length is 1 square plus 1 square plus 0 square, and this will give me square root 2. Take note of this value. I go back to earlier slide. I have 3. The magnitude of 2i plus j minus 2k is 3. And the magnitude of I plus j plus 0k is square root 2. Cosine theta then follow. So from here, I know cosine theta is 3 over 3 square root 2. Or 1 over square root 2. So you press the calculator, you find that theta is equal to cosine inverse 1 over square root 2. And this is 45 degrees. By pressing calculator, or you remember the value. For the third part, given the vector a and b, we're going to find the scalar component of A on B. What does it mean by the scalar component of A on B? Look at my diagram for the illustration. I have a vector A and I have a vector B. Now, if I draw an orthogonal projection, means 90 degrees downwards from A to B, I'm going to get a dark vector as shown on the diagram. This vector here. Now, the length of this vector is what we call the scalar component of A on B. So this is the length we're looking for. This is called the scalar component of A on B. So the answer is looking for the length. How do I find the length? Notice that you recall right angle triangle. Okay, if you have right angle triangle, usually this is angle here, then you have an opposite side, you have the adjacent side, and you have a hypotenuse here. So you know that cosine theta is adjacent over the hypotenuse. So that means that adjacent is equal to hypotenuse times cosine theta. So making use of that, we know we have this triangle. In this case, the length of A is here. This is the length of A, and you have an angle theta there. Therefore, the scalar component of A on B, by looking at the right angle triangle, we know this is equal to the length of A cosine theta. However, as we know, this length of A is 3, but theta we don't know. Now, I want to avoid finding the theta because sometimes theta is hard to find. So, I do a trick here. I multiply by the magnitude of B and then divide the magnitude of B again. Why I want to do this? Because this is magical. Why is this magical? Because the length of A, the length of B times cosine theta, or the magnitude of A times magnitude of B cosine theta is exactly A dot B, the scalar product A and B, if you try to recall earlier definition. So from here, I know that A dot B was equal to 3. And then what is the length of B? The length of B earlier we found was square root 2. So now I have the scalar component of A on B, and this length is 3 over square root 2.